Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. Finding a bug in production is never a fun experience, especially when your users find it first. Airbrake error monitoring ensures that you will always be the first to know, so you can deploy a fix before anyone is impacted. With open source agents for Python 2 and 3, it's easy to get started, and the automatic aggregations, contextual information, and deployment tracking ensure that you don't waste time pinpointing what went wrong. Go to podcastinit.com/airbrake today to sign up and get your first 30 days free and 50% off 3 months of the startup plan. To get worry-free releases, download GoCD, the open-source continuous delivery server built by ThoughtWorks. You can use their pipeline modeling and value stream map to build, control, and monitor every step from commit to deployment in one place. And with their new Kubernetes integration, it's even easier to deploy and scale your build agents. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macy, and today I'm interviewing Thomas Mansencal about Color, a Python library for working with algorithms and transformations to explore color theory. So Thomas, could you start by introducing yourself?
Hello, my name is Thomas Mansencal, coming from France, and currently living in New Zealand and working for Weta Digital and Wingnet AR. So basically I'm a visual effects artist, and I started in the industry as a self-taught person. I got my first computer around 8, I think, from my grandfather, and since then I've been hooked, and got into programming. I'm not sure when, but basically I was doing demo, as a demo maker, programming in C using Allegro, I think was the name of the library back then, with a friend. And programming was a bit hard for me, so I went into content creation more, while my friend Benoit Jacquet was doing coding part of our demos. And since then, I've been learning and experimenting in visual effects, and that's what got me at Weta. And
And do you remember how you first got introduced to Python?
So Python, it was I guess programming turned to be more like a way for me to produce tools that I need in my artistic workflow. I got introduced to Python through Maya, Autodesk Maya, which is a software we use, to do, it's kind of the backbone of the VFX industry, even though it's kind of shifting now. It has been a very strong backbone to produce visual effects, and Maya until 2006 or 2007, it's still the case, but you had to script using MailScript, which is kind of embedded language. It's very close to C, but without pointers and memory management. But then around 2006 or 7, they introduced a Python plugin to the software, and it was a big relief, object-oriented programming, dictionaries, being able to tap into Python extensive or standard library. It was a game changer. So that's where I first got in touch with Python, and a few years later I wrote a PyQt lighting assistant compatible with various DCCs, so content creation application that was allowing user to quickly create lighting scenarios in those applications. And after that, I went hooked into color science more for other reasons, but that's where I started with Python, basically.
And we've used the terms color theory and color science somewhat interchangeably so far, but I'm wondering if you can start at a high level of just explaining what is meant by the term color theory.
So I wanted to do a bit of disambiguation on that, because they might be indeed used interchangeably, but they are not really the same thing, even though they share similarities. There are bridges between them. So yeah, color theory lays the foundation, for the usage of color in visual arts. Basically, it will define the rules of color scheme creation, and the focus is really aesthetics and communication of a message. So it's based on the work of Isaac Newton. I think it's optics, it's a book publication he did back then, and so it was describing color wheels, with primary colors, red, blue, yellow, secondary colors that you create by mixing the true primaries color, and intermediate tertiary ones, by mixing primaries and secondary colors. So there is a strong psychological component to it, and from there it's only loosely related to color science and colorimetry. So color science and colorimetry, I will define colorimetry because it's important, and it's there, for many of those terms I will use, you can find pretty much an official definition by the CIE, which is a Comité International de l'Éclairage. And so they define colorimetry as a measurement of color stimuli based on a set of convention. So there is a measurement aspect to it, involving apparatus and gear, basically, to measure precisely the color. So an interesting discrepancy, between color theory and color science is in the former, in color theory, warm colors usually are associated with orange, reddish, like a sunset, while cool colors are actually bluish, it would be kind of an overcast day or ice. And it contrasts very deeply with the physical temperature of a self-luminous object. So if you were to take a red giant star, VY Canis Majoris, is temperature in Kelvin degrees is 3,500 degree Kelvins, and we say that's a low temperature star, even though it's red and orangey, and you would have the opposite Rigel, which is a blue-white star, and it's 12,000 degree Kelvin. So there is almost a reverse in the scale of things, I don't know if it's clear or makes sense, but yeah, basically in color science, low temperature bodies will be yellowish, orange, reddish, and high color temperature stuff. So warm stuff is actually blue, which is opposite in color theory. Warm colors are actually red. Does that make sense?
And for a sort of closer to home example, if you're looking at flames, for instance, if you're looking at the flame output from a propane stove or something, it generally burns very blue and hot.
Yes.
But if you're looking at a wood fire, it generally burns, reds and oranges. That's actually a lower temperature than what you would get from a gas flame, but it is visually more aesthetically appealing because of that dichotomy between the aspects of color theory that, as you were saying, deals more with the psychological effects of the color versus the color science that deals with the actual physical manifestation of how color relates to the actual temperature of the objects.
Exactly. Yeah. That's exactly it. So if you were to plot black bodies colors, you would see and you can match stars temperature with that. You would see big red giant has a very low physical temperature in Kelvin degrees, while something like Rigel is super luminous and very very hot, so it's bluish.
And what is it about color science that has drawn your attention so much, working in the visual effects field, where I'm sure a number of your colleagues don't necessarily pay as close attention to that aspect of the way that color factors into the work that you're doing?
So I guess it started, there are a few aspects. There is there are concerns when we were rendering, and there were issues back then when we were rendering, and in some companies we were rendering things incorrectly, and it's more like kind of differences between a linear and gamma space, but I won't really enter into those details now. But yeah, basically for years, like many companies have been rendering things in non-linear space, so the mass of the rendering part were kind of wrong and skewed by that, and took me like a while initially, like to understand why, but it's related to what we do in core science in a way. And the second part is more like at some point I wanted to open an online shop to sell high dynamic range imagery, high quality one, because I was not really satisfied with what was available online. Typical issues where you don't have any colorimetric data, so you don't really know like what the image were encoded with. You don't have like a color rendition chart, a color checker, which is important to assess like what the colors are representing. So there was that lack, and there was also clipping, typically when you try to shoot HDR, you take many exposures that you merge to a single image representing like the illuminance of like the environment. Problem is shooting the sun is tremendously hard. You need like neutral density filters, and everything was clamped, so it wasn't like a good representation of reality. And as a result, when you use an image like that, because the sun is clipped, the sky will take too much importance in your image, and the sun is not strong, so you are losing a lot of contrast that you would have in nature and in the reality. So I wanted to fix that basically, and I started to look at what was available online, what tools and everything, and nothing was satisfying me. And given that, the next step was to look at some stuff that was working well, and Adobe and specifically Thomas from Adobe wrote like the DNG SDK, and Lightroom and Adobe are doing very good things, but they are kind of photographer oriented, so there were many issues with that. But like the core of their product, the DNG SDK, which is a kind of the engine behind Lightroom and Adobe Camera Raw and all that stuff, was really interesting and well written. So I started to look at the spec, how they were doing things, and it took a lot of time to characterize camera properly in different illumination conditions, tungsten versus daylight. So they spent a lot of time designing that stuff, and it works quite well. So what I did was like took the spec, and with the help of Michael Parsons from the moving picture company, I wrote like a Python implementation of like the color processing of the DNG SDK, and that was my first really serious step into color science, because I needed to understand like what was happening in their color processing basically. And since then it has been kind of a rabbit hole, I would say, where I'm still falling inside.
And as you mentioned, you started working on a Python package for being able to work with the physical calculations and working with the color spaces in a digital capacity. So I'm wondering if you can talk a bit about some of the example use cases for the package that you created.
So I might continue a bit because so that part here, working with MPC was obviously private, so they are maybe still using the code, so I couldn't really take that out, even though like I was writing that as a contractor. But I needed to have some other stuff, some extra capabilities, like, okay, I have two images, I've shot like a color rendition chart, like X-Rite color checker in both, and I would like to match those images. So I needed to do that kind of thing. So from there, like it became a need to have like a Python library to do that, and I was looking online at what was existing back then. And it's either, you are a MATLAB user, so you are willing to pay, and you pay for like all that extra toolbox to do that kind of stuff, and another one, and it gets super expensive, and you are working in a closed system. Or maybe you try using Python, and at that time in Python there wasn't like too much libraries available, so I started to code mine, and I met like Michael Moderer a few months before deciding to make the API available publicly, and since then we have been working together with the contributors, to grow like the API. So I guess like use cases, it's you wouldn't use color, I would say, like as a directly as a product. I guess it depends what you want to do, but it's not something you consume like immediately as a front-end product, but it's more something that will drive or allow you to verify computations. So I guess I could give like a few examples. So basically, like at work, we need to define color management, and between the different application, the different DCC we used, and in the VFX industry, we are pretty much not using ICC for very good reasons, because originally it wasn't supporting high dynamic range imagery, so that was a showstopper, and it's kind of cumbersome a bit. Even though it has great features, it's hard to get right, and it was designed for the printing industry, literally, not really for what we are doing. So we use something called OpenColor.io and OCIO. OpenColor.io, OCIO is just consuming transformations, from that color space to that one, but you need to write them, and that's where like a tool like Color can help you defining this transformation and computing them so that you can feed them to OCIO later. So that's one of the usage. Kind of a lot of companies now are using Color as I think one of the most satisfying mail we got, because we received like a lot of thanks. One of the first, it's not the first, but one of the most satisfying mail was one from a Google engineer, and he was thanking us basically because he was using Color to verify YouTube colorimetric computation basically. So that was their way to assess YouTube was doing the right thing. It was using Color to verify their math basically, and the output of YouTube. Another one was from Merck Group, which is I think that's probably the oldest operating chemical and pharmaceutical company in the world. It may be established in 1600 something. It's super old, and they are using at least some engineers over there are using Color again to perform computation on their measurements. They are measuring spectral data, and they convert it to various color space using the API. There are a lot of publication, maybe not a lot, but a few publication using the plotting capabilities of the API also, and that's there are other usage, but that could be one somehow I would cite.
And one of the things that you were mentioning in there is the transformations between different color spaces. And for people who aren't aware, when you're working with digital imagery, you're generally going to be using either the RGB or HSV color spaces. And then if you need to convert that imagery for being able to be printed out on, for instance, paper or t-shirts, etc., then you transform to CMYK. And I'm wondering if you can discuss some of the relative benefits of some of these different color spaces and the challenges associated with converting between them while maintaining the appropriate representation of the color in relation to each other.
So it's very deep topic, and you can dive very quickly, down. But so I think we can define a color space first as a start. So usually we say that it's a geometric representation of color in space. Usually it's 3 dimensions, or can have 4, for C, M, Y, K. And I will start from basically in color science, there is a central space which is CIE XYZ. It was derived from color matching experiments by David Wright and John Guide in the 2030s. And from those experimentation, the CIE XYZ space was born, and CIE RGB, which is related. So from those, basically that's it. So that's CIE XYZ is the central space. It's a space where, for instance, if you wanted to go from RGB to lab or LUV or any color space, usually you will go through XYZ and it's a hub. So given that, the models you talk about, like RGB, it's a color model that most people are interacting with, and usually when talk about the RGB model, people are using sRGB, and that's the lowest common denominator defined by HP and Microsoft. I think it's 1996, and since then, like, everybody's almost compliant to it. It's so why RGB and sRGB are ubiquitous? It's because it's an additive color space, and there is a very direct correlation with display technology. When you add like red, green, and blue light together, you get white. So it's correlated, and CMYK is a subtractive color model. So it's very well adapted to what's happening in the printing industry because of that, because that's how inks and dyes are working. They are working subtractively in a way. So then you mentioned HSV. So HSV is a weird one, because it's we don't really use it in color science, and the reason for that is because it's pseudo lightness scale. So the value or brightness for HSB, it has nothing perceptual. It's not a perceptual color space. It will not represent like the response of the visual system to luminance. So you can't really use that space as a good perceptual space to do proper color science computation. However, that being said, it's a cool space and very useful space for artists, because you can build color pickers. It will decorrelate hue, saturation, and value pseudo lightness nicely. So it's good for that. But in color science, you wouldn't really use that guy. I just use it for anything that is more artistic related than proper mass. If you really want to do advanced colorimetry or even basic, because there are like 2 aspects of colorimetry. There is like the basic colorimetry, which is about measuring color and trying to reproduce it, and the advanced one will be the colorimetry, where you not only measure, but you try to reproduce colors while accounting for the environment the viewer is seeing things, and so you introduce color appearance models. It will allow you to grab, like, say, a patch of brown color, and that was seen in very dark viewing conditions. You have seen that dark patch to the cinema, obviously, because of contrast effects in the visual system. If you see that brown patch against a white background on a daylight, it won't appear the same. So color appearance model in advanced colorimetry allow you to predict the color of that brown patch for a daylight, for example, average condition, so that it looks and appears the same for you. So I went a bit deep, but
Yeah, a lot of these areas are easy to go deep because at the surface level, you say, oh, it's just a color. It's
yeah.
red, it's blue, it's green, etc. But then when you're talking about the ways that it's actually physically manifested and digitally represented and the ways that it needs to be transmitted in order to be able to represent it accurately at the receiving end, there are a lot of different technical and physical and scientific aspects that go into it. And there's a huge area of research because, vision and propagation of light and the ways that it works, even at the Newtonian or relativistic levels, let alone quantum, there are so many different things that we still don't fully understand about it. So
Exactly, yeah. And even in the brain itself, the reality is that vision is happening also in the brain for, if not like most part of it, it's Palmer. He has, I think I will quote it incorrectly, but is giving like a good example about vision and saying that we don't see reality. We are seeing the model the brain has made of reality, essentially. And a good example to highlight that is optical illusions. Optical illusions, they don't exist in reality. It's really your brain fighting to fit the appropriate model to what you are looking at, and not really managing to pick, okay, this is more that model or that, and that's where optical illusions are created.
And another area that's related to perception and our ability to process these visual inputs are things like color blindness, where some people are just physically incapable of even perceiving certain aspects of color. And I'm wondering if there are any uses of your library for being able to either compensate for that, or to be able to generate computations that will allow you to preview or predict the ways that somebody who has this particular limitation, how they will be able to experience what it is that you're producing.
So, it's an interesting question because for years we had a pull request. I started some code, maybe 3 years ago for that, especially, because it was a big lack, and at the time, we needed something, so I implemented the paper from I think it was a student in Spain. It's Machado, Gustavo Machado, and that pull request got stalled for 3 years because a part of this model. So there are two aspects of this model, or two implementation. There is the easy one, which is about taking the pre-computed matrices generated for his model and use that directly. We implemented that super quickly. And the other part was going back to the spectral aspect of it and being able to reproduce what he was doing with his publication. And so the model is basically based on shifting, the sensitivity of we have three cones in the eyes and rods for so we have rods and cones. The one that interest us here are the cones. So we have long, medium, short, and his model is basically simulating vision deficiency by shifting the sensitivity of the long, medium, or short cone. So for proton anomaly, which is long wavelengths or red dichromacy, it's about shifting those long cones, and you have the medium, which is the teranomaly, and if you don't have any medium cone, it's the teranopia, or tritanomaly for short wavelengths, and tritanopia if you don't have. So we needed better spectral backend in color to do that. It took us a long time, but since I think it's 1 month, even maybe. It's quite recent. We finally merged that pull request, so we can model faithfully, color blindness and vision deficiency with that. So you could have like a service online, on a web server. You upload an image and it gives you what would be the image for a dichromat or...
And I could see as well that being useful for somebody who is involved in web design to be able to incorporate that accessibility component in things like an integration test to ensure that your website is usable for somebody who has some form of color blindness, and then being able to compare the way it looks based on the different types of color blindness that might manifest.
Yes, exactly. Yeah. And you could really tune, it's probably super advanced, but because we have the spectral backend, you can really fine tune to a particular, if you know, like, okay, that's the shift in sensitivity that person has, you could very closely mimic what you will see. So it's quite good in that sense. There are probably other papers since then, because it's from 2010, but if we find something and we have time, we'll implement that. But it's still like an active research topic, because we don't really know. I think it's tritanopia. There is not really, so it's short cones, short wavelengths cone. I think there is not a really good model for it right now. So it's an area of research. It's not really well understood. I should check, but that's where I was with that.
And I had a question too about whether there are new areas of color science and color theory that you need to periodically incorporate into the library to ensure that it's up to date and accurately represents the current state of the art.
Yeah, so periodically, we are screwing like through every news or everything we can, and given the time we have also to do that, we are trying to ingest whatever is the most relevant also for us for our usage. But we do that. So I think like big area of research and of interest for us are the color appearance models and uniform color spaces, because they are important in VFX and in the game industry to do some stuff. We have a lot of use cases for that, to ensure that when you have also odd content and you are watching it under different viewing conditions, it will try to stay the same. And a good candidate, for that kind of application is augmented reality. So whether it's on the phone or inside glasses, you might be interested into doing that kind of stuff to preserve the appearance of your content, no matter like what the user's viewing condition are, basically. Yeah.
And digging into the library itself, I'm wondering if you could talk about how it is implemented and how the way that it has been built and architected has evolved over the course of the time that you've been working on it.
So very early, not at start. I guess it has grown like a bit organically at start. And so I had like kind of code that I could publicly share that wasn't MPC related. Was what it was. It was sitting in modules and at the root like of the package, and it was good. And from there, as I was starting to put even more data into the API, because I have like collection fetish, I think I have a hoarding problem, collecting too much stuff. So it has grown, and I started to segment the API and in sub packages related to a particular task, and so that's where you get something like colorimetry, which is a almost core package, and where you will have like spectral computations and all that stuff. And from that package, you have dependencies, models, which implements RGB, HSV we have, and all those color models. It's kind of, that sub-package is dependent on colorimetry, and pretty much everything is dependent on colorimetry. So there is kind of a tree of dependency of sub-packages like that. We have, I would be lying if I was saying like we don't have cross dependencies between them, but it's kind of minimal and almost self-contained. And that's how you end up like having the structure we have. So yeah, we have stuff we are doing a lot of interpolation work on spectral data. So you have an algebra subpackage with relating things for interpolation. We have an appearance one, which is very important for us, which is like all the advanced colorimetry with the color appearance models. We have blindness one, which is the one we were talking earlier for color vision deficiency. Characterization will be more like color fitting. So you have two images with the color checker and you want to match them. We have data for that, and so forth. We have a plotting one also, which is important because people are using it a lot.
And in the process of building and expanding the capabilities of the library and working with people who are using it, what have you found to be some of the most often misunderstood aspects of color and our perception of how color is manifested?
Yeah, so I guess like I could go on that question for hours. There are many things, and I think like the most important one is incorrect terminology usage. I think terminology, and I'm guilty of not using the right words at times, and I'm kind of in a shame, but I try to make a point of using like appropriate words whenever possible. And I'm sure I will be corrected many times by people hearing that interview. It's easier when you write, on paper, and you can rethink about your sentences instead of compared to when you are talking. But terminology in a scientific domain, I think is key to its understanding, and it's very true in color science. And I'm running a crusade against improper terms, and because people are careless in their usage, and you end up creating a situation where, for example, most people talk about the sRGB to linear stuff. You might have heard about that, sRGB to linear, but they don't really realize that the sRGB as a color space can be linear. So it's something that confused me in my early days. I wasn't understanding in my career, I was like, but what are they talking about, and since then, I've been trying to adopt the proper terminology, and no longer than yesterday, I was reading the physically based rendering guide from Algorithmics, and had to tell them on Twitter, guys, you need to use the proper terms. It's very confusing. You can't say what you are saying here. So, and it has been always like that in the VFX industry, especially. So, I guess it's important to use the proper words. So, because if you don't do that, that's where people start to not understand. I've been into that situation. Okay, but what is trying to say? And it's just because, you have used the incorrect wording when talking about something. And the sRGB to linear one is it's all the time.
And have there been any aspects of working on the project or working with people who are using it that you found to be particularly difficult or challenging?
I guess for me the most difficult aspect is lack of time. It's really my bane, and especially I have kids now, so I need to partition my time, and maintaining something like color and making it progress and including features and fixing issues, it take a lot of time. And that's my big my one of the big issue. Another one is most of research is paywalled, and it involves like a bit of financial resources. Like yesterday, for instance, or last week, over the weekend, whatever, we had issues about some tables in one of the CIE color appearance model, and you get conflicting version of the data. So some are coming because you are reading a publication that predates the official standard, so the data has been adjusted in the standard. Some are because there have been typo in documents taking the official standard, and you end up with errors in Wikipedia. So basically, for that particular case, I had to buy the CIE standard, so it's $60, just to verify a number. So that's a very expensive number, but it happens, very often. And it's a bit frustrating because I'm writing color because I want to spread the knowledge, and you end up like having to pay. So it's fine, I'm fine with it. But it's one of the frustrating aspects. I would be better going to cinema with my kids and spending the $60 to verify a single number. So I'm very thankful for, and related to that, I'm very thankful to the decision of some university around the world, like in Finland or France, canceling their subscriptions to journals. I think there is a very big issue when you see Elsevier's like doing billions of dollars of benefits. It's good for them, but I don't think it's really good for research. And
Yeah, it's good to see things like the Journal of Open Source Science and pre-publication sites like Archive being available to try and break down some of those paywalls and make paid research more generally available to people who are interested in applying it to their particular domains.
Yeah. So I think that would be the two big things. One of the last one, if I can put it in, is I think I wish I had like a better formal mathematical and physics knowledge. At times I'm like, I'm not really sure I understand that properly, and even though it still stay basic math, at times it can be a bit tricky, and that's where I wish I was better in that domain. And again, question of time, I don't have time to train, so
And are there any particularly interesting or unexpected uses of your library that you have found?
Yes, I mean, I think in terms of satisfaction, really, the YouTube stuff is amazing. But in terms of usage, one that I found interesting was, I don't remember her name, but somebody on GitHub, Catherine Crosson, I think. She did, and it's related to color appearance models, so that's where it's getting interesting. She did a small applet to convert. The idea is really good to convert a color scheme from a dark to a white background while maintaining the appearance of it. So you could have like a dark scheme in your code editor and user stuff to convert that to white background version while still maintaining the appearance of the color. So that was a very interesting and cool usage of it.
And are there any particular plans that you have for the future of the color library or work that you plan to do with it?
Yeah, so we are still, after 5 years, or I don't remember when I started on that, but after many years, we're still not reaching the stable level, although we are much, much closer than what we were a few months ago. The big thing we changed recently, and which allowed us to have CVD modeling, core vision deficiency, was a spectral backend update. So we have done that in 0.3.11, and Now, I think given that is done, I'm working. So yeah, that's another frustrating aspect of color science. And it's something I'm working on because we implement stuff as per the book and the reference, so that if there is something wrong, you can easily go back to the publication and check if things are agreeing. You end up having like a mix of scales. So you will have spectral computation, outputting numbers in a percentage scale, so between 0 and 100, and RGB models will be working between 0 and 1 in a floating point world. And we have Mansencal value, for example, is between 0 and 10. And so you have like all those inconsistent scales of domain and range scales. Sometimes a single definition will start between 0 and 100 and give you a number between 0 and 1. So yeah, there is all that inconsistency in the field. And it's hard to say, okay, we are normalizing everything between 0 and 1, because then like you have a color scientist, a researcher that is used to have lab values between 0 and 100, and like, yeah, why is it 0 and 1? You know, what's happening? So yeah, we talked at length about that, and without really finding a good solution for it. And actually what I'm doing these days is I'm working through that to have a reference scale, which is like as per the publication, and a forcibly normalized scale, which is between 0 and 1 for their usage. Like I would need that for my personal stuff. So yeah, that's something we're working on, and that what will bring us closer to a stable version. So yeah, that's it. We need to improve the plotting subpackage also. And there is like a ton of research data we still need to inject. I mean, like just taking a look at the issue board, you can see that there is a lot of stuff we want to implement. Something I'm also keeping a very interested and keen eye on is GPU processing. Because I'm working these days like a lot with game engines, and I've implemented the CCAM color model in Unity. And yeah, it's very, very cool to have complex color models like that being able to run in real time. But it's a lot of effort. You need to convert like all your Python code to GLSL or HLSL. So yeah, I'm keeping a very interested eyes to things like Boreum. I don't know if you heard about that. It's basically, I don't know how to describe that, but you change your NumPy import to Boreum, you know, and they're handling like all the computation on the GPU if you have one, and things like that. So it's very cool. It's a bit early days, but yeah, it will make like having access to the GPU almost as a switch. So yeah, I'm very interested with that.
And are there any particular resources that you found to be especially helpful when learning about how to effectively incorporate color into design, whether it's for visual effects or websites or display or anything like that?
That's a very good question. I think Jeremy Selan from back then, he's the guy basically that wrote OpenColor.io that we use in the industry. He was the first author, and he wrote a paper back then when he was at Sony Pictures that was called Cinematic Color. And I think it's a really good paper because it will need to be brought like up to speed. Yeah, it was laying good foundation to understand like a lot of the stuff we do in the VFX industry. And it could be useful for anybody interested to read something like that. I will provide a link for it. But yeah, in terms of websites, I think I don't really read a lot of websites. I'm more on books. So yeah, a book I love is Color Appearance Models by Mark Fairchild. Mark is a brilliant guy, super smart, very very kind. So you can mail him and he will usually answer. Don't spam him, but yeah, he will usually answer. And yeah, he has worked like on many of those models, you know, and he's a very active researcher. I really like Reproduction of Color by Hunt. Roger Hunt was like Kodak engineer, so same thing. It's guys that have defined the field a bit, especially on our end, in the industry. Let me grab that one. I don't remember the name exactly. So yeah, it's this one is more like a dictionary, I would say. It's color science concepts and methods, quantitative data and formula, second edition by Wichetsky and Styles. It's not a book you read from start to end because it's just too much. But yeah, anytime you need to have a reference to something, you open it and you will probably find what you need, especially if it's about basic colorimetry. It's really a very important piece, I think, to have if you are serious about that. And if you have it on your desk, it makes you look professional. So yeah, always good. And there are many other resources, so yeah, after the interview I can give some links.
That would be great. And are there any other topics that you think we should discuss before we start to close out the show?
So something I did forget to mention and is important because I'm involved to some degrees with the guys and the project is when I wanted to do my online shop, one of the things I was wishing for the data we would have been selling was to have them using the Academy color encoding system, ACES. I'm involved a bit in discussion with those guys, and we have a Slack channel, a private Slack channel with a few guys from the Academy and color scientists from the industry, and we have been many great conversation about the system. So it has been adopted, not widely, but still to a significant proportion in the VFX industry. And something great is people from Epic Games like Brian Carris with graphics. I don't remember his role, but he's kind of a graphics guru over Epic Games has implemented ACES into Unreal. So that's great because Unity has done the same. I helped a bit on the Unity implementation, and because of that it allows us to use the same color management solution, if I can say so. We can have data transiting from offline rendering to real-time games and being compliant and color managed the same way. So this is a very good aspect, and the Academy is responsible for that system, and that's an important topic, and it's recurrent in kind of my work around color. We are working with them often.
Is there anything else we should cover?
I think we didn't talk about... we kind of talked about it a bit, like the usage in a web application.
Yeah, so
that question kind of annoyed me because we don't really have like a direct easy usage. It's still a Python API. So what Catherine Crossan did was actually building a Flask application, and that's what she's doing. She's using she's doing calls to Color to adapt her Color syntax schemes. You could have like an obvious one is having a color calculator. You could do that, and we have some tools, some old school CGI bin scripts doing that stuff. And it's funny because it's probably the page that gets the most hits on our website. So it's very useful, even though it's old school. But nothing easy. I was talking about maybe having a REST API, but doesn't seem to be like a very high priority thing to me.
Mm-hmm.
So on an exploratory point, something I was toying with recently is Google Colab, because I always wanted to have the API available, quickly online, and with Google Colab you can actually pip install Color, and I made a very small notebook with a few tools, and you can use Color without installing anything, so it's very handy. And the days they have widgets available into Google Colab, it's going to be really cool because we'll be able to build application literally with that. But it's not now. It's not anytime soon, I think, but yeah, it will come eventually. So that's probably the way we'll expose properly as the stuff. We will be able to build calculators and things like that easily. So yeah, I will try to thank a few people, and especially like my partner, because she's very patient with me. You know, I'm spending too much time with my laptop, I think. Yeah, my kids obviously, and yeah, a few people who have been involved with or interacting. So yeah, there is Alex Forces from the Academy, Charles Pointon, which is a kind of color guru researcher, Catherine Crosson, collaborator on color, Kevin Whitley from Framestore, color scientist and people, a person with whom we are discussing a lot, Luc Canavan, contributors, Mark Fairchild for a lot of his interesting conversation and hints, Michael Moderer, obviously, which is my peer reviewer and implemented a lot of the color appearance code. Michael Parsons from MPC, with whom we started Color. Nick Shaw, who is doing a tremendous good job, and especially like he's a problem spotter. He has a sharp eye. It's insane. Ofek Lev, Paul Centore, Scott Dyer from the Academy, Sean Cooper, color scientist at DNEG, Steve Agland from I forgot the company. It's in Australia. They were Tim Borer and Yoshiono. So yeah, all those guys. And my partner. Without them, it wouldn't be possible.
Absolutely.
And all the contributors, all the other contributors in the issues and forums and mailing us, we try to put all the contributors in a file. If you raise an issue or participate, we tend to put your name in a file and on the website. So, yeah, all those guys, thank you.
And for anybody who wants to find out more about some of the ways that they can help on the project, or if they want to get in touch with you and follow the work that you're up to, I'll have you add your preferred contact information to the show notes, and we'll have a link to the GitHub project in the show notes as well. And so with that, I'll move us into the picks. And this week I'm going to choose the Beasts of Olympus series of books. It's a fun set of books that focus on the son of the god Pan and his adventures as the stable boy to the gods of Olympus. So it's a fun series that's aimed at sort of elementary school level, and I've been reading them with my kids, and they're a ton of fun, a lot of good humor, engaging storyline. So if you're looking for something to read with your kids or just as a light read for something fun to do, then I definitely recommend picking that up. And so with that, I'll pass it to you, Thomas. Do you have any picks this week?
No, I think my pick for this weekend, or I wish, was to be able to do the Coursera mathematic machine learning course. So yeah, it's starting on the 16th April. So I will send a link because I will be keen on doing that.
Great. Well, I appreciate you taking the time out of your day to join me and discuss the work that you've been doing with color and all of the research that you've done on color science and color theory and how it can be used in the visual effects industry. So I appreciate that, and I hope you enjoy the rest of your day.
Thank you. Appreciate it. Have a good day. It was good to hear you.